Hi everyone, this is Bharti here. So in my previous video about a support vector machine, we have learned about what is support vector, what is the maths behind the SVM. So in this session, let's try to understand about the kernels. What are the kernels we use, how it is functioning and all. Okay. So moving on, we have already discussed about the hyperplane. What is the hyperplane? It is a plane or a point that separates the data points, and we have discussed something about support vectors. Support vector, these are the data points which lie nearest to the hyperplane, and the margins. So margin, these are drawn with the help of the support vectors, and they should be at the maximum distance, wherein the data set will be linearly separable. Okay. So what is kernel? So why do we use kernel? So kernel, this is a function which will be used in the SVM to solve the problems. They provide the shortcut to avoid complex calculation. The amazing thing about the kernel is that we can go to the higher dimension and perform a smooth calculation with the help of it. And also we can go to the infinite numbers of the dimensions using the kernels. We have a scenario, sometimes there will be a scenario wherein hyperplane, we cannot have a hyperplane for certain problems. For some of the dimension, if we have more dimension, we cannot have a hyperplane. So when that problem arises, we can go up to the higher dimensions. Like I will be explaining you how we can go up to the higher dimensions and how we will form the hyperplanes. So kernel helps to form a hyperplane in higher dimensional without raising the complexity. So as we know, this is the complex data set which will be dealing in the real world scenario. So when we use the kernel, we will be using the three-dimensional, it will divide the data points linearly, and this one is called as a hyperplane. But how do we separate this? So in order to separate this, we will be using something called as a kernel. So in this picture, in the scenarios, we will be using the kernels. So how dimension, what do you mean by increasing the dimensions and all means? We will go with one of the simple example over here. So suppose I have X feature. So I have some of the data points here like -6, -5, -4, 1, 0, 1, 4, 5, 7, 8. So when I try to draw this, or when I try to plot this, it something look like this. So here this green point represents these are the data points and red points represents this 101. So here we can see we cannot linearly separate the data. We can linearly separate, but this one belongs to one group and this one belongs to one group. We don't want the data to be in this form. We want in such a form that wherein all this green will be coming one side and this red will be on the other side. So we want data in such a format. But we have a data set wherein we are not able to linearly separate this data. So what will happen in such scenarios? So in such scenario, what we will do is we will be taking the extra dimension we will be taking. So what do you mean by extra dimension? So ignore this for a time being. So we have this X features. So what we will do is we will take X2 and we will be naming this one as a X2 features. From X, we have taken the X2 features. So what is this X2 features contain is -6. So this is the square of -6 is that is 6, square of -5 is 25, -4 is 16. This is my one. So it goes on like this. So when we try to plot it through the graph, something it looks like this. So we have the data points, we have the minus data points, we have the plus data points, and here we can see the red points are lying under this one, and the green points, whatever is there, it is lying under the positives and the negative. Positive and the negatives, and we are able to linearly separate the data, and this line is called as a hyperplane. Sorry. So what are the types of kernel we will be using in the SVM? So basically there are 8 to 7 kernels which we'll be using, but in real world scenarios, there are like four kernels which are in very popular, I can say. So what are this? So first is polynomial kernel function, second is linear kernel function, third is sigmoid kernel function, and fourth is RBF kernel function, that is also called as Gaussian RBF kernel functions. So in-depth explanation about these types of kernels. So moving on, this first linear kernel function. So it is the most basic type of the kernel. It is one of the, I mean, most basic ones we will be knowing it, right? We will be using this as a basic type of the kernel, and it is used for the one dimensional in nature. It proves to be a best function when there is a lot of features. So when we have many features in our data set, so this is one of the best function which we can use it. And this kernel is mostly preferred for text classification problems, as most of these kinds of classification problems can be linearly separated. So we know that linearly separated means wherein we will be drawing the line and we can be separating the data. And the equation for this is k to the bracket of x1 and x2 is equal to x1 transpose of x2. So moving on next, the polynomial kernel function. So it is a most generalized representation of the linear kernel. So one of the same. One thing is here we can remember is whatever the whatever the kernel function we use, it performs almost all the same type of functions when we implement in a model. So this one, it is most generalized representation of the linear kernel. It is one or the same like a linear kernel only, but it is not preferred as other kernel function as it is less efficient and accurate. So sometimes polynomial kernel, it can be sometimes less efficient and it can be accurate also, less accurate also. So moving on to sigmoid kernel function. So this is one is mostly used for the neural networks, and this is the equation that is k denotes the kernel x1 into x2 is equal to tan. This is the function actually which we will be using for the neural networks. And moving on to the RBF Gaussian kernel functions. So as I said, this one is also, it is also most commonly used kernel. It is used when there is no prior knowledge of the given data set. So whenever there is a data set and we do not have what is there incompletely, in such scenarios also we can use this RBF kernel function. And this is the function that is k. This one is x1 into x2 is equal to exponential of this one is called as a RBF into the norm of x1 minus x2 norm of whole 2 whole square. Also, one thing we can remember over here is this polynomial and RBF kernel are especially used when the data points are not linearly separable. So, as I said, this RB polynomial and RBF and the linear, these are the most three famous kernels which it is a most three. I mean, famous in the sense it is most like every model will be having. It is one of the famous kernels. Also, we have something called as C parameter, gamma parameter, and degree parameter. So these parameters are used when we do this random search or random search CV or grid search CV. So when we are doing this random search and grid search, we will be using this parameters. So that's it for today. Let's all catch up in next session with one more algorithm. Thank you all and keep subscribing my YouTube channel for more videos.